Okay, so we're going to go ahead and get started on these problems. So these problems come from Chapter 3. They are the problems on page 132 that you were assigned to do. And I have gone ahead and I have calculated out the mass for the compounds on that, so you don't need to worry about doing those. But if you have trouble and cannot remember how to calculate out the mass, then either you need to watch another video and or you need to come in and see me about that. So we're going to go ahead and get started on this, and all we're going to be doing on these is calculating the number of moles that are in each one of these. And again, if you'll remember, the formula for the mass is to add up all of the masses of each of the elements or atoms within the compound. And so I have done that, and so that's how many grams are in 1 mole. So that's always going to be our conversion. So when we are talking about molecular mass, formula mass, whatever the case may be, then it will always be the number of grams per 1 mole of that substance, grams per mole. And you just got to remember that that's your label. So let's just go ahead and get started here. So in this case, we have 72.5 grams of carbon tetrachloride. Okay, and we do put labels down. So I have my 72.5 grams of carbon tetrachloride. That's what I'm starting with. And then I'm going to do my gram to mole conversion. Now remember, if you have grams in your numerator, grams must go in your denominator. So we have 153.822 is that value. It's that many grams per 1 mole. And again, we keep all of our labels on there. So carbon tetrachloride. Okay. And then we are going to be sure that we do our conversions and do our unit cancellations. So grams of carbon tetrachloride will cancel out. And then what you can see is the only label I have left is moles. And so the final step then is to do your computation, and your label would be moles of carbon tetrachloride. Okay, on that. Now the rest of it is just a calculation problem. And so you would multiply across your numerator, multiply across your denominator. I'll go ahead and write that in. So 72.5 times 1 is 72.5. And this 153, if you wanted to, you could put a 1 here, would be 153.822. And now I'm going to just divide that out. So 72.5 divided by 153.822. And so that value is 0.4713. Now I'll go ahead and write those all out. But we're going to come back up to our original problem again. It has 72.5. So my number of significant digits are 3. So that is all I'm going to need here for that. So it would be 0.471 moles of carbon tetrachloride. And then that would be my final answer. Okay, so now let's go back again. The expectation is that you will always record your grams of your compound, whatever your compound is, grams of your compound, moles of your compound. Again, we're going to do our unit cancellations just to show that the moles are the only thing that are left. Multiply numerators together, denominators together. Here's my division. And then again, I'm going to do my significant digits. Okay, so that would be problem A. So B, we are starting off with 12.4 grams. I believe this is sugar. Okay, sucrose. So we start off with our given. Again, I've already calculated this out to be 342.296 grams per mole. Now, according to which periodic table you're using, this might be slightly different on the end there. So again, I'm going to do my mole to gram conversions. I've got grams in the numerator, so grams must be in the denominator. And I know it's kind of a pain to rewrite your compounds and so forth, but we do that. And that again is for 1 mole. Okay. So again, I'm going to do my unit cancellations. So grams cancels with grams, numerator to denominator all the time. I am left with my moles on the numerator. I'm running out of space over there, so I'm just going to work down. So multiply across 12.4. Multiply across 342.296. Again, we're going to divide that out. And I get 0.0362. And I need 3 digits, 362. So if you want to at this point, go ahead and do the correct number of digits. You won't need to write that step necessarily down. Okay, so there's my correct number of digits. I need 3. I have 3. And get your label on there. So it is moles of C12H22O11. And then again, that would be my final answer. So again, you started with grams. Whatever you start with, what's in the numerator goes to the denominator. Your moles on top. Again, we're remembering that our label is always grams per mole. Grams per mole. Okay, let's do one more. So I'm starting off with 25.2 kilograms. So a little bit of a twist there. Okay, so in this case, you can either do this within the problem, or if you want to do it over to the side and just do a decimal movement, that is fine. If you put it into this, you must do it as a conversion factor. So we know that 1 kilogram is the same as 1,000 grams. Okay. It's okay if you don't put a label on that. So this is, because this time you're doing a unit conversion. I'm not converting on there, but you're definitely also could if you would like to put a label on those. So again, I have kilograms. So now I am labeled in grams. And now I'm going to do my 1 mole is, and again, my value is up here. So that is 26.036 grams. Okay, grams per mole. I'm going to go back in and I've got my grams changing with my grams. So if you look at that, everything has canceled. All I'm left with is moles. And now I'm just going to multiply across. So again, if you want to put that over 1, you are welcome to. It's 25.2 times 1,000. I'm going to just move my decimal. So 25200 over 26.036. I'm okay if you don't, put that step in, if you're okay with running things in your calculator here. So I've got 967. I only have 3 digits. That would round to an 8. 968. Please check my calculations. And it's moles of C2H2. Okay. And again, that would be your final answer. So again, if you're doing a gram to mole conversion, it's just one step. If you're given your grams, use your grams to mole conversion factor, put the numbers in. Do not forget to do your unit cancellations. Do not forget to use your sig digs. And don't forget that if you need to go to exponential, to do that also. So this would be an examples of gram to mole conversions, page 132, problem number 61.